All right, so welcome to 2025 Knoxville BSides. For those who don't know me, you will. I come to about every BSides in the East Coast, so it feels like that way. I am Morgan Rogers. I help run. My wife runs Foxpick. Let me get that out of the way. But I help run Foxpick. I also do all the engineering for Foxpick. And Knoxville was gracious enough to ask me to do their badge this year. So without further ado, we'll kind of dig into what this badge does, what it's made of, and I'll take questions at the end. But hopefully by the time we're done, you'll be able to put your name on it, maybe add some time to it, show you what we can change and what we cannot change, and then I'll give you the access to the code so you can make it what you want. So tips, tricks, and tribulations, but this is an ESP S3 badge. So basically it is It is basically the flagship that ESP puts out. It's not C6 is, but the ESP S3 is kind of the most supported chip out there. So if you're like, hey, I want a chip that does Bluetooth and Wi-Fi and all the little AI tools and runs on MicroPython, it will do that. So I kind of put that on there because it's kind of the budget chip that does everything you might want to do. So basically, it's got 45 GPIOs built into it, ADCs, again, your Bluetooth, which is BLD5, and your Wi-Fi 2.4 gigahertz. So kind of does everything. If you want in the future, you want to like, I want to make this, pull this badge out, probably do it. So the very basics I put on here, so we'll go through that, but the basics come out to be just, I wanted to give everybody a feel for what this chip will do, put a screen on it, all little passive touch deals, a little bit of a Wi-Fi deal, and a little bit of Bluetooth built into it as well. So we can kind of go through all that works. This mic can be so close to my mouth. Kind of weird. So first screen. Oh, look, we get the B-side screen there. But yeah, the buttons do work now. So if you hit like left or right on the left side, you'll flip over to my screen. So you can see the Foxpick logo and all that. So that's kind of how the graphic simulations work on the screen, which is if anybody cares, an SSD 1309, but no one really cares about any of that. But so in the code that I will give you the access to on the site, it has like what pins you have to hit and all that kind of stuff. As far as the constructor has to be built to run that screen, but it was pretty much the budget screen available at the time, so that's what I went with. But so basically, this is how graphics get put to the screen. It's like a glyph push. So we pull in and we pretty much populate the entire screen to like a page swap. So kind of easy. This screen 2, we're like, what does this actually do? I hit the little button and get Oompa Loompas on the screen or something? What is this, right? So this shows you how many Bluetooth devices are around you. So if you hold it down, it like will populate, and then the MAC address at the top is actually the one closest to you. So if you hold it down, it starts a little scan, and it's like, I think every time I've done it here, it's maxed out. So I don't know if there's like, Bluetooth stuff in the ceiling and all this kind of stuff, but it is like really strong. By the end, I'll show you how to like tune it down so you can kind of tune in stuff that's just right next to you or within 5 feet of you. But I think it's reaching out and grabbing stuff within like 30 feet of you. So it's kind of grabbing everything in the moment. At my house, it's like 7 things, so it's not a whole lot. But yeah, it's always like, wow, everything here has Bluetooth presenting out of it. It's kind of crazy. So, but that's that little screen there. So basically, that kind of goes through what it can do as far as Bluetooth scan, repeat, and pulling MAC address and data from Bluetooth from that chip. So again, when you look at the code, it's like, oh yeah, that's how it does it. Obviously a battery voltage screen, so you can kind of get a real-time view. It updates every couple milliseconds, so you can kind of see how much draw you're doing. This I put in there, so there's obviously a function in there that you can pull out that says, okay, this is the pin it uses for battery. This is what it measures, and the conversion to actually get that power out, because it's obviously we're reading across some resistors and stuff, so we don't really want to measure ADC values. We want actually voltage values. So that equation is in there, the offset's in there, and all that kind of stuff. So you don't like, what's the math? We don't worry about that. It's in my code, so you have to worry about it. Also, discharge. Lithiums don't discharge. Oh, we got a question. What? Oh, God. Yeah. You know what? What's this button here? Yeah. All right. So, battery screen. So, lithiums don't drain in a linear fashion. They drain in more of a a reverse log, we can call it that. So the function for that is in there too. So, as you say, my proximity to getting dead is really in there. It's really how much battery power you actually have, so it's kind of neat. But as an EE, is what I am. I'm sorry, I didn't introduce that early on. I get into the details of how circuitry works, batteries drain, all this kind of stuff. So for me to say, I take, 3.2 to 4.2 and I divide it into fifths here and then divide it out, that's not how batteries drain. So I was like, it would eat me up. You're like, it's been at 1 bar for like an hour. But yeah, no, that's not how things work. So, but. And then this your name here screen, I was like, how do I test this? What's this? I would like my name there. It'd be cool. So there is a serial interface built into the board itself, so we can actually talk to it, and you can type your name in using a little bit of code, not a little bit of code, type it in. It's not a big deal. And you'll put your name up there, and then where it says no time, if we enter some Wi-Fi data, it will grab the Wi-Fi time, and it'll disconnect, and then it'll keep that time updated until you turn it off. Your name value, any sort of other values that we set are put in place, they stick. So you turn off and on, your name doesn't go away, the Wi-Fi data doesn't go away, your strength of Bluetooth doesn't go away, all these little data files don't go away. The only thing that goes away is, again, the time, because we have to update that. There's no RTC or real-time clock on this chip, so we have to bring it in from somewhere and then stick it, and then I can count it. So, but. I will get to that. Yeah. Oh, so you can hit the buttons at the bottom? So maybe it wasn't clear. I don't know. Up, down on the left side gives you the different screens. Left, right will change if the screen has a change on it. And then on the other side, there's a status light on the back. Left, right will actually change that status light. Again, it's just there so you can kind of see how it does it or how the code works to do that. And then up, down, well, it doesn't anymore, but it used to change the number of Oompas, but it doesn't really change that anymore. But yeah, left and right will change the color of the NeoPixel on the back of the board on the right side. And then left and right on the left side will change the actual screen if it has a separate screen there. So how do we talk to this thing? That's what everybody wants to know. So it has a CH340 chip, so we have to have the CH340 driver. It is the UART driver for the chip. The chip, you can use what they call the virtual interface, which is a VSI, and basically it's a virtual serial. It's not reliable and doesn't give you serial out all the time, so I hate that one that's built into the chip. So I actually put a serial chip on there that does the UART conversion for you. However, because I don't feel like paying TDI's prices and to have their garbage driver and their chip that dies for no reason at all when they update the driver, I put the CH340 on there. So Google a basic CH340. There are hundreds of sites that show you Adafruit, and all these will show you how to install that driver. It's fairly easy. And then you'll plug it in, it'll show up as a COM port, and then we can start typing to it. So pretty easy there. You'll need a USB Type-C cable, C2C, works. And then we'll also be needing PuTTY or the Arduino IDE. I recommend you go ahead and download the Arduino IDE. I purposely chose to write all the code in that just because it's easier to understand. It's pretty common. Most people have familiarity with it. And it's just, the libraries are there for you. I usually write in Express's standard stuff because then you have access to all the registers and whatnot. But as far as getting your feet wet into these kinds of chips, the Arduino side is so much easier to get through. The libraries are there. You can just hit, I need this, and download it. Does this compile? Great. Burn to it. None of this weird setup or stuff. So I recommend we use that. I'll be using that in the demo, and we can kind of go through and get to talking chip now. About that. So when you plug the chip in the Arduino IDE, it will actually do a little reset for you. And then it'll give you this little command menu. So these are the commands that you can use to go through and change what you said. Like say we have the name, the Wi-Fi, the password, the timeout for the screen. You can reboot the badge. If you don't like any of the data you have on there, hit the reset. It clears all those stuck deals inside. You can change how fast the scroll rate is for your name. You can turn on the debug, which pretty much just prints out what it's doing in the terminal. You can change the time zone. Say you went to Nashville tomorrow. Then you can change it to CST, you know, and then you can change the cutoff for how sensitive the Bluetooth scanner is. So the lower the value, the greater. Well, say, excuse me, first that. The lower the value, closer to 100, I guess I should say, the more it will see, right? The lower the value, closer to 35, the less it will see. If you go below 35, you have to be almost on it to see it. So, all right, so let's just talk to this thing. Boring stuff. So if you don't have anything in there, there's a reset button on the back. Click it. If I did it right, click in. Come on. See, that's why I didn't sacrifice to the demo gods. I'm 11. We're gonna, or not. We're on comment. All right. There we go. So it'll give you the menu. If you hit the reset button, and then we can say, oh, I want my name in here. Just type name, all lowercase, and then your name. Should give you a prompt saying, I change your name to whatever. And then if we turn the badge on. Now I can see my name's here scrolling. So really simple, really quick. If I turn it off and on again, it'll be there. So you shut it once, you forget it. Beyond that, time zone, again, same thing. Type it in as it is in there, caps count, and set it. So pretty simple, pretty easy. Any questions about setting names or anything like that real quick? No, nothing? No? Okay. So let's go to the code. Why not? Why not? So I wrote everything in the Arduino IDE, which is hard for me to do because it's very, I say, flat to me. So basically, I structure everything in a way that's kind of broken out. So the user, I could have just all done it in one page, but it gets confusing with header files and all this and images and all this stuff and stuff. So the images have to be in what they call, so there's BMPs and then there's XMPs. XMPs are the hex version of BMPs, right? So if you do it in XMP, it's easier to get the glyph out to write to the screen. So there's lots of XMP converters out there. Just Google it, I guess, and drag it in. It converts it. Pull your hex out and change the variable name, and then put it in. So any logo I have up here, you can make, and then just drag and drop it in. As long as you put the include, you can call it. So it's just a variable at that point. So you want to write a variable to the screen. So I scroll to the bottom of all this. All you have to do is just page paint it. So pretty easy, pretty quick. It's using the U8G2 library. So very robust library for writing Arduinos and screens. That's how we've been using for 14 years. So it's very, very robust. Just add it. Lots of examples, lots of things to go through. The only thing you need to really worry about is I close my menu. Is the constructor. So this is the constructor you must have to run the screen with the variable. As long as you include my header file, all the pins are accounted for. So nothing beyond that. But everything else, I wish you to go through, change what you want, make it your own. Be like, I want this kind of thing. The ESP will probably do it. I want to use MicroPi. It will do it. It will eat a lot of battery and run clock cycles, but it will do it. So if you're more familiar with that, load the bootloader on there. It runs it. One of the first badges I was doing, I did put through the MicroPi, but because I didn't want them all to be dead before lunch, because they would be, I had to go back to C++. So I think I actually wicked the battery down in less than 30 minutes. So we talk about cycles, wow. But you can be really efficient with the cores as far as the the C++ goes. So, but I did like writing in MicroPy, so if you're more familiar with that and you have it plugged in, it does it, right? Or whatever, you can add a bigger battery to it, do that too, right? So not a big deal. But I want to just go through and say that all the code, I hopefully commented well enough for you to use. We're always bad about that, right? We go back and comment after the fact. And there's a couple things in there I know I added at last minute that I didn't put the comments in there. But it's mostly there just so you can go through and say, hey, this is how we do this. I broke everything out. Every screen's a function. So how that screen gets painted, what's painting to the screen's now a function too. So you can say, okay, here's how this little snippet of code works. Here's how this snippet of code works. So you're not trying to like go through massive amounts of lines. Just go to the bottom, and you'll have the breakouts of how things actually get put on the screen or work themselves out. So I didn't want to go through a lot of like tedious code for everybody, but just go through and say, hey, here's this work. And then at the bottom it says page 1. So you can look at page 1, and then in page 1 are the functions for how page 1 gets painted. So it's pretty simple. I like to say elegant. It is not. You know, my elegant stuff is reserved for high-end stuff that I design all the time, but this stuff is more of a, let's get everyone out there making something, doing something with Arduino, doing something with ESPs, and kind of getting out of the user space and into a little bit of the maker space. So I broke the IOs out on the back as well. So the IOs I'm not using, you can solder to and use, so I didn't want to be like, oh, you can't use those. You can use them, they're there. The ones I'm, of course, using, you can't see, but yeah. Any questions so far? Before I just draw on. The what? So if you scan the QR code in the back, you go to my site. In the top link, there's resources. This thing is labeled BSides Knoxville 2025. So it'll take you to my GitHub. I would like to say there's a lot of public stuff on my GitHub. There's not, I'm sorry. I have a lot of IP I have to protect, but that is on there and open. As I add things or whatever to other badges, you'll see that populate too. But right now, it's just that badge, so it's pretty easy to see. But, any other questions? I think I'll put a link to the driver on there too, so it's a little easier to find. Because it's the CH340, and there's, if you go to the actual CH340 site, I think it's all in Chinese, so you need to like translate it. So the WCH, who makes that chip, they make a lot of nice chips no one's ever heard of. That's one of them. They make a lot of great processors no one's heard of, and they're cheap. So they make an Arduino clone for 20 cents. Out there, so it's actually, if you go to Nash tomorrow, the badge I did for those actually has one of those on there that runs all the LEDs because it was cheaper than doing it with actual, with anything else. It was just like, okay, I could do it with transistors and stuff, or I could just code it. So it was easier. It's a chip and LEDs. It was in like a nickel to produce. It was weird. So. But yeah, it's a great platform. Not a lot of support for it because, again, no one knows about it. But if you're familiar with how microcontrollers work, I would recommend ordering an eval board for let's call it 32 V003s. Yeah, and they're CH32Vs. And they're a fantastic little chip that does everything an Arduino will do, plus it's faster and runs lighter on power too. So, so any questions beyond that? I'm going to wrap this up. Yeah. It will. A couple things about that. So when you plug it in, if it's on, it won't actually load your COM port because it goes into charging mode and it doesn't sync itself up. So if you turn it off and then back on, it'll stay that way. But you have to be off to actually get it set the COM port first. I have to do that for battery protection reasons. You'll actually get a short through if you plug it in and it's on. And it's like, hey, I'm on and the battery's connected. So there's a blocking circuit that keeps it from happening. But no, it will run on USB power just fine. It's just if you're going to talk to it and it's on when you plug it in, it won't sync up because it holds that circuit open for you. So there's a protection circuit that keeps it from like getting hot. So it does charge while you're using it though. So if you had it on, I have it here. It's on with the battery on it. It's charged. It's fine. It shuts itself off. So I put all the battery protection circuitry in there. What's not on the board is actually on the battery itself. So there's no really chance of it catching fire, we hope. Unless it's a battery manufacturing problem, but yeah, I went ahead and we designed a lot of that back end to keep that from from happening, or shorting your computer out or anything weird like that. So a lot of detail was paid to the power side. About 3 minutes was paid to the other side of the chip, but weeks were done in sim and design for the power side, just because I'm very particular about power, because that's the dangerous side of the world, right? We're actually taking this 3.2 volt or 3.7 and boosting it to 14 volts on here, right? So then we have to run the back of this screen. It's low amp, so not a big deal, but yeah, we have to take these voltages and ramp them way up to run the LEDs and all that kind of stuff. So there's a lot of detail paid to this side of the board to make sure that was safe and didn't blow caps up or all kinds of crazy stuff. So done it in the past, so learn from your mistakes, I hope. But no, so as a day job, which is it's not this. I am an EE. I design custom electronics for microchip design. So that's kind of what I do for a living, and so there's a lot that goes into designing stuff that doesn't exist. So that's what we have to do, right? So so I sit around and have to think of every way we can break this, and then try not to break it, and that's and we fail a lot of the times. That's how it works, right? So you always break something, or you get something backwards, or you run it out. But yeah, so to do stuff like this is always like the fun side of it. I actually get to use my knowledge and training and to sit down and design pretty much toys, right? That's how it works. So the toy maker is kind of fun. But so I literally do this on my weekends, and I enjoy it. So I was happy when Nash and Knox and 4 others came to me and was like, I want you to design our badge. I was like, sweet, I'll do that. I like doing stuff like this. It gives me something to learn, right? So I'm always thinking, hey, let's learn something new. What's it going to be? And you're like, where do you start? But when people come to you with a project, it's like, oh, I get to learn new stuff and and see what it's about. So I recommend as you play with it, go do the same thing. Like, what can I learn? Google, what does ESP32 S3s do? What can I do with it? So everything on here is pretty much, you bought a Adafruit Feather or the dev mod boards or any of the ESP32 S3 boards with the OLEDs on them. Same star circuitry within range, and so it will do everything those little boards will do, except I gave you the benefit of having the touch pins brought out to touch pads, so you're not sitting there with like a wire and some foil or something, right? So you get nice touch pads on it, stuff like that. But see how many Bluetooth things. See, it just lights up. So Bluetooth everywhere in this room. So that works out. Any more questions? Yeah. So due to scale, there's a lot of people here, a lot of badges. We had to outsource that. Sadly, with EPAs and all that, we always have to go overseas for all this stuff. That's how it works. Most of the electronics are made overseas. Unless it's a processor, it's probably not made here. So it's got to be a processor or a power tray, something like that, something big. They're all made here. Small discretes are typically made overseas, so it's all had to be ordered China or Philippines or somewhere else. Before tariffs, I got these in, so it was a chore, but we got it worked out. But I am actually changing everything over to a Filipino board house, and I found some local assembly houses. I'm actually going to be one of them. So the pick-in places and screen machines and all that are coming to build these things. But mostly because now there's demand for it, right? We didn't have a demand before because you could have them produced for $1 a badge per se. But now with tariffs and all that stuff, that's changing. Good and bad, I guess. There's no real infrastructure yet, so it's bad at this point. But maybe in the future it'll be better. Who knows? It really depends on what comes of it and if it sticks. So. But yeah, so as your question, I guess we had to outsource a lot of it because of production runs and volume, things like that. There's just nowhere in the States who could do it affordably, so we had to do it that way. Yep. I know that you mentioned, you have to outsource this overseas. Do you have any contacts or you recommend that are not like hostile countries? Yeah, it depends. Okay, Yeah, currently there's a lot of U.S. base houses now. They're smaller, so depending on your scale, it comes out to. There's actually a house down in Augusta that does stuff too. But I'm currently looking at. So Batelli it smells like beetle. I think it's Bittle, is a Canadian house. I think their board house is actually in China though, so it's kind of like they're a Canadian house for assembly, but the board house is in China. But so beyond that, there's some Philippine houses. I think there's a couple of Mexico places too they're starting to do it. But it's primarily been a China-heavy place thing, and they have everything in place for it because they've been making electronics for so long since the 80s, right? Let's be real. Since they moved everything over there, and since they had the warehouse and all that, they have a lot of these. In fact, to the point where they actually have their own EDAs, so their own software built into their house where you can design their board in their software and just hit buy, right? So PCBWay and Easy EDA, which is JLC, do that. So it's just if you're kind of wanting to get your feet wet into EDA and design, you can use their tools and export the Gerbers and order your boards from somewhere else. But the tools are free and robust. So because a subscription to Altium is like $2,000 a year or something. So no one wants to do that. Question? So overall, yes and no. So the cost is around about that. So you have to factor in shipping, taxes, and all that too, right? So there's some other costs tacked onto there. So if you were like, oh, I parred this board out, but because I order in volume, of course, now we can slide that price down a little bit too, because you order 1,000 of these processors, they're now not $3 or $1, right? So you can kind of get priced to them. But like if you had an unpopulated board and you went to build it today, it'd be about $42. So mostly because tariff costs have brought some things up. But. Any other questions? Up here? Yeah. So as a microchip tester, I have found, so typically these problems occur on the analog to digital side. So anything we're taking an analog signal in and converting it to digital and reading it out, that's where we see a lot of degradation. It typically happens over the course of heat, because now these resistor arrays start to get more resistive or less resistive depending on the heat. And so you start to see a lot of flux based on heat. Arduino's bad for it. Clock is also can swing around a lot because of that. Things with internal clocks, I think the C2 from ESP has a little bit of variance there. Not enough to matter. Arduino was designed to run off a resonator, which has a lot of error already. So it kind of works stuff out. I wouldn't use an Atmel 328 for much of anything other than running basic back-end stuff that doesn't require a lot of precision. Beyond that, you want to get a precision chip that does that. So, the S3 I've found to be the S3 module. I don't know about the actual chip itself. I don't really buy those because it's a lot of overhead to get it to work. The modules seem to be really, really well. They just work really, really well for for doing the Bluetooth and Wi-Fi. They don't do 5 gigahertz or Wi-Fi 6, but as far as those kinds of timing things, they work really, really well. So the clock is very square on this chip, and typically you see a sawtooth clock on a lot of these chips because it's just not designed well. It's just, okay, there's a up and a down, but the slew rate is almost a 45. It's terrible. The square waves on this, if you look at the SPI and put a scope on it, are just clean square waves. It's fantastic on this chip, but I was shocked actually. I'm used to seeing very skewed or curved lines on these things, but for this thing to be nice and square, I was surprised. So yeah, and it's probably why I picked that chip too. It was just very robust, clean, mid-grade chip around. You can always go more expensive, I guess, but for that chip, it just does everything any little hackerspace might want to do, right? So it has all the wireless with the antennas built into it, as well as all the capacitive touch, screen-driven protocols are built in. So your I2C and SPI are both on chip. They're not like a bit bank scenario, which is why we can, on the code, it's hardware, not software based. So yeah, that's a great chip. But again, the other stuff, 18 mega, the Arduino Megas are fairly good too, as far as running servos and all that kind of stuff. If you come to the Foxpick table, I have some games. They're running off I think I use the 328s in all the locks, and then I'm using an ESP to actually drive them on. So, yeah. Yeah. So I commented the code as best as I could based on like how my wife read it and her question. So now she is an engineering background, just not where I am at. So it was more of a, are you techie, but maybe you're not, an engineer. So I commented things as just to make it so where I want to do this, and the variable names make sense. It wasn't, so I bothered to type out a variable name that's like long, right? So it's not like, what does TR mean? No, none of that kind of stuff. It's, time register or something. It's actually written out. So you're not trying to like go through and figure out what I was trying to make of it. I didn't use a lot of pointers unless I had to. So anything where a string is handled, if anyone works with string values in process, in any sort of code, it's always a const pointer somewhere because it's easier to pass. And with microcontrollers, you have to hide it that way because it's basically an array of characters that I have to point to as a string. But I try to limit that as much as possible, so you're not going, wow, there's all these ands and asterisks in here. What's he talking about? Because that gets confusing. And so I try to. Actually, the code is very large for this chip because I was very verbose in how it did it. So it was like, okay, I can't use a pointer. I can't be like, okay, everything gets pointed back to here and save all this variable space. I was like, here's a variable, here's a variable, here's a variable. They're all like ints, they're not like 8 and 16 and 32. I didn't like define them. It was like, okay, they're all just int values, so it's easy to read. You're not going, why do you make this an 8 and why is this a 16 and why is this a 32? Because the color for the LED is 32 bits. A lot of the variables could be in int 8, but things like time and all that need to be in a 16, right? So, because your clock goes further out. But yeah, just like that where it's like I didn't bother to go through with that deep because I knew there'd be a lot of people new to code looking at it. And when you start going into code design and why you pick this, that's a whole different class, right? That's where we have to sit down and go, why, what's the end, what's going to use it, where's it going to go, what am I putting it on, how's it going to be used in the future, what kind of temperature we're setting at, stuff like that. So there's all kinds of things we have to think about when we're dealing with the real world and microcontrollers when we actually write the code, because we have to sit down and think about everything and then make it fit in this nothing of space, right? And nothing of cycles, and the speed is, an eighth, a 16th of what a computer would be, right? So to make it run fast and work well, we have to really be explicit in what we do. But for this code, I was like, I can be explicit, but let's make this easy to read, structured in a way that's easy to read, and break out everything into a function that we can. So the actual running code is very short, but how it does it is very long. So as you read through it, you're not going, what does he mean by this? And if you get to a point, my email's on that page, right? Just shoot me an email. I hope I don't get expected a ton of them, but I do answer the questions as they come. I'll probably put them on the GitHub as well as I answer things, so you can always post a comment there too. So, and I'll answer them as they come in. But also, if you want to make a branch of it, make a branch. I want to see what people make. So that's how I learn. I'm like, did you know you could do this? No, I did not. I might have done it. So go ahead and make a branch, do what you want to do with it. So, got 5 minutes here. Anybody got a question? Is a standard SAO if you want to populate it. It will run 3.3 volts. It's got the I2C built into it as well. So if you wanted to, I don't know, make a light up thing that's controlled by I2C from the controller, you could do that as well. So I went ahead and ran it because I had the space and the I2C lines were freed up. So that's a relative term. I've been doing this for 14 years. So for me to, it took me probably 2 months of design to get the power circuitry done. These are based on designs I already do though. So these circuits were designed, it's basically how do I make them work on this board? So as far as values go and all that, those are defined already for me. So, but getting the fit, component selection, all that, and I say 2 months, but it's 2 months of weekends and time. It wasn't like consistent. And then the tool, I used KiCad, I think, for this one. I swap around a lot because I get questions on a lot of them. And in order to answer questions on a lot of EDAs, I have to like use them all. So I actually swap around. I use the Altium suite for a lot of my stuff just because it's the pro version. I do it for a living and it's what I have. And it goes quick. I don't like Altium for reasons. Mostly it's expensive and there are things about it now they got bought out by Renaissance I don't like, but that's here nor there. But as far as a free tool goes, Easy EDA has a pro version that's free and permanently free. That's really, really good. It's coupled with JLC, which is a board house in China, but it is a very robust tool. Their parts are attached to it, so you can actually, assign parts that you can actually buy and things like that. Which that's always been the headache in design is this part an active part? Does it work? Where can I buy it from? All these things. So the libraries are attached to it, so you can sit there and build your bombs and build all this kind of stuff with it. I say bombs, B-O-M, not anything explosive. Bill of materials. There's a lot of acronyms out there. So basically, it's a nice tool to say, I need a resistor that's 220 ohm. You just go to the thing and resistor into 220 ohm, and it builds that for you. So now you have a shopping list as well as your design. So it's a really well laid out tool. And for anyone getting into it and just want to see and get the feel of schematic work, it does that kind of stuff. If you want to get into like simulation, like Spice and all that, or the P-Spice type stuff, there's a couple of online editors around. I think Forstall or something like that is a nice drag and drop online, put a resistor there, put a cap there, and you can watch the current go through the stuff. So you can kind of build circuits and like, oh, it makes the LED flash, or if I do a transistor with this and it charges, stuff. So yeah, so you can kind of watch how things work in like the very, very slow clock time too. It's like, 1 second, a millisecond or something. It's something long. So you can actually see how long it takes a cap to charge or something like that. So beyond that, if you want like a good book on circuit design, there's a book called Circuits for the Inventor, I think it's called. And I actually reference it a lot, even though as a professional, it has a lot of these circuits broke down for you, and you're not having to go through and design them yourself. It's like these are known circuits that are used in the industry every day. Don't invent the wheel; just put the wheel on. Right? So modify it for your, for your design, but don't try and invent it. It's been done. Even what I do, we have tables, and it's like, hey, I need to make this do this. We say we have a cap of this value, we need voltage this value, and we drag across and resistor this. It is, we don't do the math like we used to anymore, so because it's been done. So, any other questions before I wrap it up? Yeah. How hard would it be to add a video card? To add a video card. To that? Yeah. I don't even know if it's possible. So right now the video actually shows up, and we're actually saying, okay, it's a 1 for black and a 0 for white, And so I make a matrix of that whole screen, 128 by 64, and then we paint it. So it loads the registers and paints it. So we're doing. So if you want to make an animation, all you got to do is sit there and say, okay, we cycle through with a frame rate. And in the code, I have the frame rate. And so I have a variable that goes through. We track the loop time, and when that loop time hits a 0 for the most part, then we paint the screen again. So that way we're not overpainting or underpainting. All right, I think that's it. So again, make it your own. I would like to see some code and some branches on my GitHub come out, and what people are doing with these badges. And next year, maybe bring it. I want to see it because I'm interested in what they can do too. There's a lot of projects for ESP32s out there, so it'll run them all. So give it a go.